From studying the dusty surface of the red planet Mars, to plunging into the hellish atmosphere of the wasteland Venus, over the last 60 years, we've launched hundreds of unmanned, robotic vehicles into space, on complex trajectories to visit each of the solar system's planets, providing glimpses of our neighbouring worlds our ancestors once thought to be unattainable. But for all the fascinating discoveries and amazing achievements made along the way, humanity's journey towards the stars started out in a much darker place. A battlefront between the world's then two great competing superpowers. Their enduring dystopian arms race, which gripped the world for more than 40 years, was underpinned most of all by the development and deployment of weapons of mass destruction. Intercontinental nuclear-armed missiles capable of wiping out entire cities. And just when it looked like these two enemies might actually obliterate each other and bring about the end of civilization, they suddenly found a new use for their many rockets, and a new way to channel their competition.
We have vowed that we shall not see space filled with weapons of mass destruction, but with instruments of knowledge.
Всем советским людям особенно приятно, что коллективы научно-исследовательских институтов.
Consider again that dot. That's here. That's home. That's us.
A daring and dramatic goal that was not destined to be realized on this day.
1, 0.
Our story begins at the height of the Cold War, as the two great geopolitical superpowers of the time, the United States and the Union of Soviet Socialist Republics, sought to upstage one another by demonstrating technological superiority. It wasn't long before space emerged as a battleground in this standoff, initiating what has come to be known as the space race. The Soviets fired the starting gun with the launch of the first artificial satellite, Sputnik, in October 1957. And they continued to set the pace in the coming months as they launched the first living thing aboard Sputnik 2 to observe the effects of orbiting on its body in preparation for future crewed missions to outer space. Fearing that the Soviets were lurching ahead in the overall pursuit of global supremacy, the Americans kicked into life and got serious about spacefaring. In January 1958, the US launched their first satellite, Explorer 1, which discovered Earth's Van Allen radiation belt. Later that year, the US's National Advisory Committee on Aeronautics, or NACA, was dissolved and replaced with a new administration that would set their sights on the stars, the National Aeronautics and Space Administration, better known as NASA. And it was NASA who would then resume this tussle with the Soviets, repurposing old ballistic missiles into rockets as each side launched their own fleet of competing weather satellites and probes. By this time, nestling a satellite in a low Earth orbit had been mastered by both sides, and the competition soon shifted beyond the bounds of this planet to its nearest large body, the Moon. And with Earth's natural satellite now the grand prize, each side set about devising their own lunar exploration schemes. And long before the inauguration of the world-famous Apollo program, NASA established the Pioneer program, an initiative to eventually land probes on the surface of the Moon, which started out with tests to escape Earth's gravity. The first Pioneer probes were simple, carrying television scanning systems for beaming back images of the moon's surface, microphones for detecting tiny meteorite particles in space, and magnetometers for studying Earth's magnetic field. But their first 3 attempts at launching these probes all ended in failure, allowing the Soviets to claim another milestone in the space race. In January 1959, their Luna 1 module became the first probe to perform a flyby of the Moon, before entering into a heliocentric orbit around the Sun. Another 2 months would pass before the Pioneer program got off the ground with Pioneer 4, the first successful attempt by the Americans to reach escape velocity. While a guidance system failure meant it actually missed its lunar target, its other instruments nonetheless revealed fascinating new insights into interplanetary space and the radiation environment surrounding Earth. And with the Soviets still firmly leading the charge towards the Moon, NASA broadened the battleground of the space race with the other terrestrial planets in their sights. For both sparring superpowers, Venus was the obvious choice for a maiden voyage to another planet. This is because every 19 months or so, Venus's orbit aligns it with the Earth, presenting an opportune window for a relatively straightforward, minimum energy journey between the 2 planets. A number of these windows came and went in the early space age, with neither side quite ready to take advantage of any occurring in the 1950s. In fact, the next successful Pioneer probe, Pioneer 5, was originally intended to be a mission to Venus, but technical and developmental problems resulted in NASA missing the window occurring in 1959. As such, Pioneer 5, and each of its 4 subsequent missions thereafter, would be reassigned as interplanetary space weather missions, examining solar wind, flares and ionization in the area between us and our neighbouring worlds. Meanwhile, NASA would commission a new program of more advanced probes to enable the frequent exploration of the solar system, starting with a flyby of Venus once the next launch window rolled around. Like sailors exploring uncharted seas, these would come to be known as the Mariner probes, and would make use of NASA's soon-to-be-ready deep space network of worldwide ground stations for satellite communications. But before the program could get underway, the Soviets would claim yet another win in the space race, perhaps their most seismic yet, as Yuri Gagarin became the first cosmonaut to enter orbit aboard Vostok 1, and make it back alive to tell the tale. This left the American side desperate for a win at the start of a pivotal decade for space exploration. And though their first attempt ended in failure, the subsequent launch of Mariner 2 would mark a turning point in the tussle, as the Americans would seize the initiative. Mariner 2 successfully launched from Cape Canaveral on the 27th of August 1962, embarking on a perilous voyage to Venus that was beset by technical issues and malfunctions. But despite its bumpy ride, the spacecraft made it to Venus in one piece on the 14th of December that same year, becoming the first probe to perform a flyby of another planet, and providing the US with their first big win of the space race. Mariner 2 probed the Venusian atmosphere, measured its temperature, and discovered the absence of a substantial magnetic field around the planet, before drifting off into space and ceasing its operations. A follow-up Mariner mission, Mariner 5, would return to the planet some years later in 1967, to validate and reaffirm the former's findings. But in the meantime, with Venus under the Americans' belts, both sides turned their attention to another of our terrestrial neighbours, the red planet Mars. Unlike Venus, whose surface is concealed beneath a thick, opaque layer of highly reflective clouds, Mars's surface is globally visible and relatively unobstructed. We can see its many features, faults, and craters from space, rendering it a much more tantalizing target for a flyby. And like Venus, Mars also aligns with the Earth along its orbit once every 780 days, about 2 years and 2 months. And so, during the earliest convenient launch window, in November 1962, both the US and the Soviet Union launched their own maiden Mars-bound missions, with varying degrees of success. The Soviets' first attempt, known as Mars 1, launched on the 1st of November, but contact with the probe was lost shortly before arrival at its destination, and the mission ended in failure. NASA, meanwhile, made 2 attempts with their Mariner program, launching Mariner 3 and Mariner 4 a few weeks apart later on that month. While the former was lost during its launch, Mariner 4 successfully managed to escape Earth's gravity, setting out on its long journey to the Red Planet packed with sophisticated new instruments. Equipped with a camera, magnetometer, and ionization chamber, as well as a cosmic ray sampler, dust detector, and plasma probe, this floating laboratory survived its voyage and made its closest approach to Mars between the 14th and 15th of July 1965, coming within 10,000 kilometers of the planet. It snapped the first 24 grainy images of the surface of another world, revealing cliffs, craters, and shots of the thin Martian atmosphere. And in doing so, ironically upended the hope that we'd find Mars to be a bustling colony of life like our own. But instead of canals and reservoirs of water postulated by astronomers from the previous century, Mariner 4 revealed Mars to be a dusty, deserted wasteland, its surface evidently exposed to the harshness of space for millions of years on end. 6 years later, elapsing the Mariner 5 mission to revisit Venus in 1967, NASA prepared another pair of Mariner probes for another expedition to Mars, known as Mariner Mars 69A and 69B. Back then, NASA used to launch nearly identical probes in pairs, given the many previous failures arising from launch malfunctions that blighted their early missions. This time around, however, both probes were successful in exiting Earth and making it to Mars, following their respective launches in February and March 1969. They both performed flybys of the Red Planet in July of that same year, snapping more than 200 photos and increasing the charted portion of the Martian surface to around 20%. However, their revelations, among them the discovery of ice-filled craters in Mars's south polar region, received less than usual media coverage, having been overshadowed by a much more defining moment in the space race. A week before, astronauts Neil Armstrong and Buzz Aldrin became the first people to set foot on the surface of the Moon during the legendary Apollo 11 mission, dealing a near knockout blow to the Soviets, which left their pursuit of technological supremacy on the ropes. Having been beaten to flybys of both terrestrials and now the Moon landing, the next logical step would be to establish a more permanent presence around these two worlds. And 2 years later, in 1971, both NASA and the Soviet Union launched their own pairs of Mars probes, tasked with assembling our clearest picture of the red planet yet by not just flying past, but by orbiting the planet. NASA's first pair of Mars orbiters, then known as Mariner 71 models H and I, lifted off in separate weeks of May 1971, but only the latter, today known as Mariner 9, made it all the way. It arrived in orbit around Mars on the 14th of November, only narrowly beating the Soviet pair of orbiters, Mars 2 and Mars 3, which lifted off a few weeks after Mariner 8. All three probes then set about studying the red planet, but only one was able to overcome a major unforeseen stumbling block. Upon their arrival, all 3 spacecraft found the Martian surface enveloped by a worldwide dust storm, covering the planet with featureless grey clouds and preventing meaningful observations in the month that followed. But while NASA engineers were able to stow Mariner 9 in orbit until this storm had cleared, both Soviet probes immediately executed their pre-programmed tasks, using much of their available power and capacity to photograph the blank, dust-shrouded Martian landscape. It was only after this storm had cleared that Mariner 9 was then reactivated, spending some 8 months amassing a collection of more than 7,000 images, which increased the mapped portion of the Martian surface to 85%. In doing so, it uncovered a plethora of jaw-dropping new geological features missed by previous missions, including its massive Western Hemisphere volcanoes, among them Olympus Mons, by far the largest known mountain in the solar system. It also uncovered a gigantic equatorial canyon stretching for more than 4,000 kilometers across the surface, which was subsequently named the Mariner Valley. And most importantly of all, it found yet more tantalizing signs of an aquatic past on Mars. Evidence of erosion, weathering, and riverbeds from a bygone age where water once flowed on the red planet. And with such intriguing potential teased from the surface, the next step for scientists would be to get down onto the very ground, to land a probe on Mars and study it grain by grain. The Soviets would try this long before the USA. Needing to pull off something drastic to turn the tide in the space race, landing missions quickly emerged as their ace in the hole. In fact, both of their Mars orbiters that accompanied Mariner 9 were equipped with detachable landing modules, each containing the earliest recognisable Mars rovers. However, neither was successfully deployed. Shortly before reaching the Red Planet, Mars 2's lander was dropped on the 27th of November 1971, but its parachutes failed to open, and all further attempts to contact the probe failed as it plunged into the dusty desert below. Mars 3's lander, on the other hand, did successfully open its parachutes and completed the first soft landing on the Martian surface on the 2nd of December. However, it only remained operational for a further 2 minutes after touchdown, not nearly enough time to release its rover. In fact, the only thing the probe was able to beam back during its brief spell on the surface was this image. To this day, astronomers are still divided over what it shows. Some claim it to be the first grainy picture of the Martian horizon, while others simply dismiss it as static and interference. In any case, the Soviets discarded the image, concluding it to be of no scientific value and writing the landers off as a failure. And each of their subsequent attempts to land on the surface of Mars ended in the same way. They would never touch down on the red planet's surface again. But somewhere they would enjoy more success in this endeavour was Venus. Having been beaten to a flyby almost a decade earlier, the Soviets spent much of the 1960s working towards a more direct approach, sending probes deep into the Venusian atmosphere. After 3 initial unsuccessful attempts as part of their Venera program, the big break came on the 18th of October 1967. When Venera 4 became the first atmospheric probe to plunge into Venus's choking toxic clouds. It returned data on Venus's temperature and chemical constituents down to an altitude of about 25 kilometers, before being crushed and melted by vice-like atmospheric pressures, some 20 times greater than on Earth. In the 3 years that followed, 3 additional Venera probes would breach the planet's cloud tops, refining its measurements down to altitudes of around 10 kilometers. And then in mid-December 1970, Venera 7 went one better, as it became the first probe to successfully land on the surface of another planet, beaming back a weak signal for around 23 minutes. Though not equipped with a camera, the probe still determined the composition of Venus's atmosphere, measured its high wind speeds, and endured its blistering surface temperature of 475 degrees. This marked a turnaround in fortunes for the Soviets right off the back of the moon landing, and throughout the 1970s, they would double down on increasingly sophisticated Venus landing missions. In 1975, Venera 9 became the second probe to touch down on the planet's surface, this time carrying a camera among its range of mounted instruments. As such, it returned the first ever panoramic pictures of the barren, lifeless Venusian ground, strewn with jagged rocky debris. And by the 1980s, Venera probes were snapping full-colour panoramas of its surface, providing our clearest window yet into this unforgiving, inhospitable landscape. The Americans, meanwhile, doubled down on Mars as a place to snap shots of otherworldly horizons, while also searching for signs of life beyond the Earth. The revelations of Mariner 9, which had teased just how water-rich Mars used to be, elevated its exploration to the summit of NASA's wish list, prompting them to pour vast sums of money into developing a series of next-generation, longer-term Mars orbiters. Carrying over successful designs from Mariner 9, they established the Viking program, constituting a pair of dual-module orbiters equipped with sophisticated landing probes that could carry out persistent research on the Martian surface. Despite a project cost of more than $1 billion all the way back in the early 70s, these twin spacecraft returned on their investments and then some, spending 6 years building up the lion's share of everything we know about the Red Planet today. Viking 1 was launched on the 20th of August 1975, and entered orbit around Mars on June the 19th of the following year. Viking 2, meanwhile, was launched a month after its twin, and joined it in orbit on the 7th of August 1976. Both orbiters would spend their first month of operation scanning the Martian surface for a suitable landing site, one where the Vikings could perform biological experiments probing for signs of Martian habitability. Viking 1's lander was dropped on the 20th of July 1976 into Chryse, Planitia, where it returned the first ever clear image of the rocky Martian surface. The second lander, meanwhile, started its descent towards Utopia, Planitia on the 3rd of September. Over the next 6 and 3 years respectively, these probes would then perform extensive analyses of the Martian soil, characterizing its rock formations and determining its geology. In the meantime, the orbiters would continue to circle the planet, acting as a relay for beaming landing data back to Earth. And throughout the duration of their missions, they uncovered troves of even more compelling evidence for a once water-rich world that played out on Mars's surface, when they saw river valleys, streams, floodplains and grooves etched into the Martian bedrock. The Red Planet was once more Earth-like than we ever could have known, with huge standing bodies of water larger than the Great Lakes. Today, however, that world has vanished, irreversibly lost to space with the sun's gradual stripping away of the Martian atmosphere. But perhaps as much as 4 billion years ago, the Red Planet may have once looked blue, and made for the earliest habitable abode for life in the young solar system. While we can't get too carried away, Many of the ingredients for an awakening of life on Mars have been seen in its formerly aquatic environments. And even if only primitive, the discovery of a second source of life in the solar system would have seismic implications on our perception of the entire galaxy. If microbial life once existed on Mars as well as Earth, then it probably exists anywhere where the conditions are right. From the sealed-off, tidally heated oceans of Europa and Enceladus to the seafloors of distant Earth analogues identified by the Kepler telescope. Therefore, one of the final acts of the Viking orbiters was to scout out possible landing sites for future missions investigating Mars's habitable past. Probes capable of not just operating on the surface, but traversing it. However, the technology to execute such a feat was still over a decade off. In the meantime, NASA would turn their attention to the final unexplored terrestrial world, Mercury. Mercury represents by far the greatest challenge when it comes to flybys of the terrestrials. As the closest planet to the Sun, the solar radiation it endures is around 5 times more intense than in the space surrounding Earth. This has the effect of degrading a probe's instruments as it approaches the Sun, and presents further problems when trying to stabilise the craft to perform a flyby of Mercury. Attaining the velocity needed for a probe to reach this vicinity, moving inwards from a heliocentric orbit against the outflow of solar wind, would require an enormous amount of fuel, unless we could accrue momentum via some other means. For example, astronomers had noticed previously that when icy comets passed by a planet and felt its gravitational influence, they seemed to leave the system faster than they entered, as they were slingshotted by gravity on the way out. Applying this technique to a probe would not only circumvent the need to carry a heavy payload of fuel, but would also enable and indeed necessitate a probe to visit multiple worlds in a single swoop. As such, the 10th and retroactively final installment of the Mariner program, Mariner 10, would carry out an ambitious voyage to Mercury to study its geology and its surface features, while also swinging by Venus along the way to receive a gravitational boost. Mariner 10 launched from Cape Canaveral on the 3rd of November 1973, but unlike its predecessors, budget constraints had squeezed this mission and whittled it down from a pair of probes to a single craft designed for maximum cost efficiency, making its journey to Venus fraught by difficulties that much more worrisome for its engineers. After surviving the turbulent first leg of its journey, Mariner 10 encountered Venus on the 5th of February 1974, and imaged the planet until it departed on the 13th. During that 8-day stretch, it snapped over 4,000 pictures, including the first close-up images of the planet, a year before the Soviet Venera 9 probe touched down with a camera. It studied Venus in a variety of wavelengths, and made the first detection of its vanishingly weak, tenuous magnetic field. After carrying out its sophisticated gravitational slingshot maneuver, Mariner 10 departed Venus with a spring in its step, allowing it to press on with the most complex phase of its journey around the Sun. And in the following month, the craft executed the first of 3 Mercury flybys over the course of a year. On March the 29th, 1974, Mariner 10 flew just 700 kilometers from the planet, allowing it to compile intricate mosaics from both sides of its heavily cratered surface. It then looped back around the Sun as Mercury completed 2 orbits, before making a second flyby in late September, from a farther distance of about 50,000 kilometers, returning yet another mosaic showcasing an even greater portion of the planet. And then finally, in the following March 1975, Mariner 10 came back around for its closest flyby of Mercury, passing just 330 kilometers from the surface and snapping the most detailed set of images so far, including close-ups of its craters, maps of its various planes, and observations of its terrain in both colour and false colour. Almost immediately after, however, the probe started to malfunction irrevocably, and veered away from Mercury into an unreachable heliocentric orbit. And barring the remote possibility that the craft has since impacted with a large object, it is probably still out there, circling our neighbourhood star to this day. We've been back to Mercury just the once since then, when in 2011, NASA's Messenger spacecraft arrived in orbit, carrying a much more advanced, hardy and sophisticated range of instruments. After making a single flyby of Earth and 2 of Venus to rack up its speed, Messenger pushed onwards towards Mercury and studied it for around 4 years, snapping more than 100,000 images in just the first year of its operations. By 2013, it had mapped 100% of the planet's surface, charting its unseen side and examining its broad selection of craters. It uncovered signs of past volcanism, organic molecules, and even water ice in the planet's north polar region, as well as shedding light on a number of the violent impacts it endured in its past. The Messenger mission concluded on the 30th of April 2015, when the probe failed to reappear on the Deep Space Network after passing behind the planet, presumably because its unstable orbit decayed until it crashed, leaving yet another scar behind on Mercury's tormented surface. With the completion of Mariner 10's mission to Mercury, each of the 4 terrestrials had now been visited and explored to some degree, and the only way we could now improve on our orbiters and landing modules would be by traversing the surface of our neighbouring worlds. As mentioned, the Soviets had tried to deploy vehicles on the surface of Mars during their failed landing missions in 1971. But it wasn't until well after the breakup of the Soviet Union 2 decades later that NASA finally honed the technology aboard their first Mars rovers. Remote-controlled cars carrying onboard laboratories, which could be driven across the Martian surface while being controlled from Earth. But the first successful Mars rover was a far cry from the heavy-duty research factories seen on the planet today. Sojourner, deployed from the Mars Pathfinder mission, was a low-budget attempt by NASA to test if it was even possible to operate such a vehicle. It was about the size of a microwave and ventured less than 100 meters from its landing site in Chrysi Planitia. But over its 83 days in operation, it analysed Martian rocks and soil and collected data on its atmosphere and climate. Its success inspired NASA to double down on a fully fledged program of advanced spacecraft and rovers, among them the Mars exploration rovers Spirit and Opportunity. They were launched in June and July 2003 and dropped on opposite sides of the Red Planet in January of the following year. Both would then venture for miles beyond their landing sites, aiming to pin down precise parameters for Mars's warm, wet past. Rover A, aka Spirit, spent 6 years roaming the Martian landscape, studying the geology and minerals in the Gusev crater for signs of chemical processes driven by contact with water. It found the rocks in the crater to be made from volcanic basalt, which did indeed show signs of interactions with small amounts of surface liquid. Rover B, on the other hand, known as Opportunity, landed in the Eagle crater of Meridiani Planum, which ultimately proved to be a more hospitable environment, with greater access to sunlight and more sheltering from Martian dust. This allowed its engineers to prolong Opportunity's operational life to almost 15 years. Covering more than 45 kilometers in that time, it extensively imaged the Martian landscape and took stunning panoramic pictures of the surface of our neighbouring planet, many of which captured the eyes of the world and drew attention to the plight of NASA's rovers. And as intended, it also successfully identified signs of groundwater impacting the rocks and soil of both the Eagle and Endurance craters. Then, in 2019, after almost a decade and a half in service, Opportunity's batteries ran low and its engineers switched it off for the final time, clocking out with an emotional message to melt even the coldest of water ice. But by that time, the rover had been joined on Mars by its successor in the program, Curiosity, when in 2012, the Mars Science Laboratory touched down in the Gale crater. Armed with a drill, among several other instruments in its extendable arm, Curiosity burrows into the Martian soil in search of the building blocks of life: carbon, hydrogen, nitrogen, and oxygen, as well as organic compounds and signs of how water may have interacted with each. Among its most eyebrow-raising findings was the revelation that the Martian soil is still around 2% water, allowing scientists to refine several key values in models of Mars's atmospheric and geological evolution. Curiosity remains active on Mars's surface as of the making of this video, 11 years since it was first switched on, and its mission has been extended indefinitely, with its robust build and clever engineering leaving no end in sight for its operations. In 2021, it was joined by the latest edition of the Mars exploration program, Mars 2020, an orbiter which delivered a similarly sized, slightly more advanced rover named Perseverance, this time with an extra trick up its sleeve. In addition to the rover, which also drills for rock samples searching for signs of past microbial life, Perseverance came equipped with another deployable vehicle, perhaps the most intuitive NASA has ever constructed. Ingenuity is a groundbreaking Mars helicopter probe that has been hailed as a Wright brothers moment in our quest to conquer the Red Planet. Upon detaching from Perseverance, it has carried out more than 60 successful flights in 2 years of operation, and its technology is a trailblazer whose successful designs are paving the way for similar future missions to the moons of gas giants. In just 60 years, we've gone from barely being able to escape Earth's gravity to operating and manoeuvring on the surfaces of other worlds. The Mariner program allowed NASA to reach all 3 of our neighbouring terrestrials and set the stage for an unprecedented age of technological development and exploration. With the long road to Mars now well established, and the technique of gravitational slingshotting practiced with Venus, NASA had all the tools to press ahead with the next phase in humanity's spacefaring, travelling to the outer solar system where the giant planets lie. And around the time Mars landers were starting to materialise with the Viking program, NASA revived its old, dormant Pioneer program to undertake perhaps their greatest voyage yet, into the uncharted territory of Jupiter and Saturn. And in the next episode of this 3-part series, we will follow them out into the darkness as we embark on a journey to the gas giants.